Hello students, here is a small video that I've made to help you with the homework on chapter 1. Remember that you've already watched the lecture video, you've taken the quiz, and this is just a summary of what is going to really help you in completing the homework on chapter 1. Remember that physics is a science of measurement. We are basically measuring everything that we can, whether it be length, mass, time. We are trying to quantitatively find out how much it is. So physics is a science of measurement. Now, and all physical quantities require standard units to be measured and represented in. And mainly we focus on length, mass, and time in this semester. Although we have other quantities, we are mainly focused on length, mass, and time. And you all know that the standard unit of length is meter, the unit of mass is kilogram, and the unit of time is seconds. And whenever you pick a unit, there are two important attributes that are required. One, they must be precise, and two, they must be reproducible. So they need to be precise and reproducible. And then all equations need to be dimensionally correct. So that means they need to be consistent with respect to units. For example, if you have density is mass divided by volume, and you substitute the unit of mass, which is kilogram, and volume is in meter cube. So now we know that the unit of density is kilogram per meter cube, kilogram per meter cube. So all units need to be consistent. Once again, the SI units of length, as I've mentioned, mass is a kilogram and time is seconds. So although we are used to other units, like feet, pound, and all that stuff, miles, and we don't use all that in physics. We just use meters, kilogram, and seconds. And we need to be able to convert from one unit into another. So I'm just going to show you an example of conversion. We know that 1 meter is 100 centimeter. Centi means 100, or rather 1 by 100 actually. So a centimeter is 1 by 100th of a meter, or 1 meter is 100 centimeter. Okay, so if 1 meter is 100 centimeter, what is 1 meter square? Is it just 100 centimeters squared? No, it's not. 1 meter square is 100 times 100 centimeter squared, which makes it 10 to the power 4, because there are 4 zeros. Now what about 1 meter cube? 1 meter cube is 100 times 100 times 100 centimeter cube. So that's 10 to the power 6 centimeter cube. Now remember that if you go the other way, 1 centimeter is 1 by 100th of a meter, and that is 10 to the power negative 2, because it's 1 by 100 and the 10 raised to 2 goes to the top. So that's 10 to the power negative 2. So you must get used to writing quantities in the scientific notation. Instead of putting all those zeros and decimal places, you should be able to represent them as 10 to the power of either a positive quantity or a negative quantity. Okay? So that's one part of the homework. Now when it goes to other conversions, I'm just saying that 1 meter is 1,000, or in other words, 1 millimeter is 1 by 1,000 meter, which is 10 to the negative 3 meter. There are other prefixes that you need to know, like kilo. Kilo stands for 1,000. So 1 kilometer is 1,000 meter. You would have heard of micro. Micro is 1 by a million. So 1 by 10 to the power 6, which is 10 to the negative 6. So you need to know some prefixes. Now, significant figures, we've spent a lot of time on the lecture video, but here are some examples. If you look at a number like 7.15, there are 3 sig figures. Okay, now that one has 4 and 43 has 2. We all know that. And whenever you multiply or divide, the product or the quotient, the answer should be represented with the lowest number of sig figures. We know that. So, if you multiply these three numbers and you put it into a calculator, this is what you get. But you cannot put the answer that way. You cannot. That's not correct. So you got to look at the lowest number of sig figures, which is 3 in the first, 4 in the second, 2 in the third. So this answer should only have 2 sig figures, which means it's 2400. Because when you put it in the scientific notation, it's 2.4 times 10 to the power 3. So 2.4. There's only 2 and 4 that are sig figures. Okay? So whenever you multiply or divide, you give the answer with the lowest number of sig figures. But that is not the case when you add and subtract. So this is one place where students make mistakes. So here's the example of adding the same three numbers. So we're going to add 7.15 with 8.003 plus 43. Now in this case, when you put in a calculator, that's what you get. Now whenever you add or subtract, you are not concerned about the number of sig figures, but you care more about the number of decimal places. How many decimal places do you have in 7.15? Oh, just 2, 3 and 0. So you have no decimal place in this number. Of course, you have no decimal place because it's just a whole number. Okay, so keep in mind, we're looking at the number of decimal places now. And what is the lowest number of decimal places? It's 0. Therefore, the answer must be 58. Keep this in mind. It's important for the exam. So 58, that's the answer. Moving on, I got a couple more slides. When you look at the scientific notation, which we have already used, the number should be written with the decimal after the first non-zero digit. After the first non-zero digit. So we got 346. The first digit is 3. So the decimal should come after that. So it should be written as 3.46. But that's not the number given. So you got to add, multiply it with 10 to the power 2. Because we have to move the decimal point 2 places to the right in order to get to 346. So the decimal is at 3 points, it's between 3 and 4, and to get to 346, you got to move it 2 places to the right. So that's why 10 to the power 2. Let me give another example. 0.00527. Can you try that? Okay, 0.00527. Where should the decimal be? It should be after the first non-zero digit. The first non-zero digit is 5. So it should be written as 5.27. But now we got to go back 3 places to get to where the decimal was. Let me show you. So 5.27 times 10 to the negative 3. Why negative? Because we're going to the left. Okay? So 36.5792. Easy. The decimal must be after 3. So between 3 and 6. And then we got to move it 1 place to the right. So that's 10 to the power 1. Okay, so that's basically how you put numbers in scientific notation. Now, why is it that important? Because it's easy to find the number of sig figures. Like in 0.00527, you have 3 sig figures, 5, 2, and 7. So if you put it in scientific notation, it's so easy to find the number of sig figures. And all final answers must be given in scientific notation. So here is converting one unit into another, a specific example which will help you on the homework. 1.7 nanogram per milliliter. Nano rhymes with 9. So that's 10 to the power negative 9. Nano. And then you've got milliliter. Milli is 10 to the negative 3. So now you got to change this into grams per liter. Okay, got to change it into grams per liter. Let's do this. So first of all, we got to have 1 gram is 10 to the power 9 nanograms. So don't be confused there. 1 gram is big. So 1 gram by 10 to the power 9 nanograms. Okay? Times, now you got to convert liters into milliliters. So 1,000 milliliter or 10 to the power 3 milliliter is 1 liter. So when you do that, you see you have 10 to the power 3 on top, 10 to the power 9 below. That is 10 to the power 6 below, right? 3 and 9. So you got 6 below. But 6 below means negative 6 on top. So it's 1.7 times 10 to the negative 6 gram per liter. Now, there are so many moving pieces here, so you please have to look at this very carefully and try to understand. All right, what do we have next? So here there is another conversion coming up. Convert 1 gram per centimeter cube into kilogram per meter cube. Now this is the unit of density. 1 gram per centimeter cube is the density of water. But if we want it in kilogram per meter cube, what we're going to do is 1 gram per centimeter cube is given. First, we know that a kilogram is 1,000 grams. So a kilogram, 1 kilogram by 10 to the power 3 or 1,000 grams. And then what did we see? 1 meter cube is 10 to the power 6 centimeter cube. Okay. And now when the units cancel out, we see those two are gone. Gram cancels out the gram and you are left with 10 to the power 3. Because you got 10 to the 6 on top, 10 to the 3 below, that's 10 to the 3 on top. So that is going to be very important whenever you change gram per centimeter cube into kilogram per meter cube, just multiply with 1,000. So as an example, if it's 0.8 gram per centimeter cube, it's just that times 1,000, which makes it 800, right? Makes it 800 kilogram per meter cube. You may just leave it as 0.8 times 10 to the 3, which is good, or you can put it as 800 kilogram per meter cube. So, like I said, this is a short video meant to help you on your homework. Thank you. See you on the next video.